And how is your preparation for your intern? Okay. Did you get the weightage?
No,
Did
sir.
you weightage
sir.
for it's given in the announcement. Just check. And
Yes,
if you
sir.
get,
Through mail is also given.
yeah. So it's given in the announcement the weightage for your end-term exam, so you can prepare accordingly. So all of you go to this joinpd.com. Just Google this joinpd.com and use this code LXRNIC. You'll be able to participate here. So I can see 25, 26 of us are here, but only 12 of you have joined. So go to this joinpd.com. We'll wait for another 2 minutes and we can start our class.
It says practice for graded assignment.
Right. Yes, all of you go, please go to
But we have
joinpd.com.
given the graded assignment, right? We have submitted it.
Right. So it is, don't consider that as a practice for graded assignment. Consider this as, a questions given to you and you are solving with me. So consider this as solve with us. Okay.
Okay, sir.
Yeah.
Yes.
Actually, the graded assignment as per our schedule and as per our live session, we thought we will be keeping it on Wednesday, but for some reason it did not happen. So, but the session again, since it was scheduled, so we just kept it as it is, and we were just going. So, anyways, it's okay. Don't go with the name of this presentation, but as you know, this is something you solve with us, right? So let it be like that. So you can learn here, and you can by solving with us. So that's how it's going to be. So let me start the class. So I hope all of you joined here, or those who haven't joined can also join now. You can just Google joinpd.com and use this code LXRNIC. So do not give any space in them and you'll be able to participate. Okay. So is there anyone who is facing difficulty to join the session? If not, we can start now. So as you are already aware that this graded assignment, everything has been submitted, so it's fine. It's okay, you can still practice here because this is not the graded assignment question, it's like similar questions. And the best way of learning is this thing is you should actually practice whenever I'm giving you some time to solve. So try to solve that by yourself and participate here. Okay. So
Yes.
let's do that learning here. So I think by now all of you are aware how to participate here. So I'll just skip these slides. You also know how to participate till now. So I just want to know this test problem, how confident you are with respect to maths 1 content, considering your interim exam. So you can just give me a random response. Let's see.
60%.
Okay. So let's see the response. Very confident to get GPA of 9 and above. Very good. Need to revise and build up the confidence. Yes. Not at all confident. Okay.
So week 10 and week 11 graded assignment solution is provided or not, sir?
I think it's not provided yet, but it will be provided either today night or like tomorrow morning will provide.
Okay, sir.
Yeah, definitely will do that. So as you are already aware that the weightage for your interim is already given. So you can see that these 2 weeks has a significant weightage, right? So pay attention to the learning here.
Sir, I didn't got the mail about maths. I just got the mail about stats. Can you tell me what is the weightage?
Yes,
It'll
sir,
be given. It'll be given in your announcements.
Sir, in the announcement section there, where, sir?
I'll show you. See, all you
Okay,
have
sir.
to do is go to your Seek portal and go to announcement.
In mail also, sir.
Even it goes to the mail also. So here you can see on the top itself informations related to maths 1 interim. So you can see here the weightage for n term, right? Right. So you can see week 10 to 11, it's like 25 to 30% is been asked. So you can see like equally almost all has significant weightage, right? So you can
Yes.
plan accordingly. Well, let's go here. So we can see that most of you are need to, need to revise to build the confidence. So that's fine. That's perfectly understandable. So let's do the learning for week 11 today. And, we can again, go ahead with the other things, right? So you can see that week 11, like some part of what we had left it before, like let's say what we learned initially was up to what I feel is like till in week 10, we studied till DAG, right? Directed acyclic graph. And then there were two
Yes, sir.
applications of DAG, like topological sequence and one more thing is longest path, right? So that thing was there. And then there were
Longest
more, then there were more with matrix multiplication and then, these kind of things. Well, and like the next part of week 11 is more about algorithms, right? So there are various algorithms, right? So all you have to know is like how does this algorithm works, and that's all. It's like this week, like week 10 and 11, if you understand, it's done, you get full marks here, right? So, and it's not like any other weeks, let's say a function or a calculus type, wherein we can actually complicate more things here. So it's like very straightforward. All you need to know is what are these things, that's all, right? So let's understand what are the various algorithms here. Okay, so it's like we had seen it's just a question to all of you. Maybe I can just myself tell you, or you can just yourself tell me here. I'm not asking you to type it or something. You can just unmute yourself and speak. Just tell me, to find the shortest path from a fixed source vertex to every other vertex in a graph G with no negative edge weights, which algorithm will you use?
Dijkstra.
Or maybe you can put your
Dijkstra.
answers in the chat window. I can take it from there. So you will use Dijkstra. Can you use any other algorithm?
Sir, Floyd-Warshall.
Or what about Bellman-Ford?
Yes, sir. Bellman put, but for negative concept, sir.
No.
And
It's not
But it is, sir,
mandatory.
it is, sir, applicable, sir. It is applicable, but
Applicable,
it
right?
will be easy to use Dijkstra.
So yeah, it is easy to use Dijkstra, right? So all of you, I can see like most of you giving answer as Dijkstra. So Floyd-Warshall. So let's see why we cannot use. Okay, you can use Floyd-Warshall, but again, this has got a different application altogether. But let's see. To find the shortest path, so I'll repeat this again. To find the shortest path from a fixed source vertex to every other vertex in a graph G with no negative edge weight. So basically, there is no negative edge weights. So which algorithm you should prefer is Dijkstra, right? What about the next one? Okay, so this is Dijkstra. So for this one, to find the shortest path from a fixed source vertex to every other vertex in a graph G with or without negative edge weights. So this is the only change here. It
Bellman.
may or
Floyd-Warshall.
may not have a negative edge weights, but we have to make sure that there is no negative cycle, right? So which algorithm will you use for this? Put it in the chat window.
Bellman-Ford.
Right. So we can see that most of you giving answer as Bellman-Ford. So well, that's good. So I can assume that some of you at least know, not most of you. We are like 50 of us here, but participation is less. But I assume like this is understandable, right? So see, there is just a slight difference, right? If you have a negative edge weights, all you have to do is just go with the next one, that is Bellman-Ford, right? Okay. Now, if you have to find all pair shortest paths, that means we are not defining any source vertex here. If you have to find out all pair shortest path with or without negative edge weights and no cycle and no negative cycle, which algorithm will you use? So put it in a chat window. The third one, Floyd-Warshall, right? So all of you says Floyd-Warshall. So now you can understand, right? Like there is
Sir,
something.
but why no, sir? But why negative edge weights without negative edge weights?
With or without negative edge weights?
Oh, without negative edge weight also we can use.
Both also, yes. Okay. In that case, you'll be able to use this one. What about if you want to find out minimum cost spanning tree? I don't know, since I haven't told you yet, but still, assuming that all of you have seen the video.
Prims and Kruskal.
Prims or Kruskals, you can use any of them, right? So you can actually use any of these algorithms to actually find out minimum cost spanning tree. So we can just go ahead with all these and see how does all that thing happen. So now we understood like these are the primarily main algorithms that is being used, right? So Dijkstra is there, then we have Bellman-Ford algorithm, then we have Floyd-Warshall algorithm, then we have Kruskal algorithm. So of course, now you can see that, some of the algorithms are little hard to do. Maybe like this Bellman-Ford algorithm, I can say it's kind of hard to do. Not hard to do, but it takes time basically, right? All we have learned here, what you have learned is, and you would have also seen questions in your activity and the practice assignment, that this Bellman-Ford algorithm, it's actually takes time for doing, right? But there are other ways of asking questions on Bellman-Ford algorithm that is again can be done. But yes, so what else? Like we primarily these are the algorithms that you have to focus on week 11, right? So now what is Dijkstra algorithm, right? So you already all of you have seen and also told, and I assume all of you know that a Dijkstra algorithm is basically used to find out the shortest path from a fixed source vertex to every other vertex in the graph, right? So that's what we do. Then what are some of the facts? It is applicable for weighted graphs with positive weightage, right? So basically this is not applicable for negative weightages, right? So something should trigger you that if you are to ask to find out from this source vertex to any other vertex, what is the shortest path, which algorithm will you use? It's Dijkstra. And also that you have to make sure that there is no negative edge weights, and this is kind of easy to do manually when you're using this Dijkstra algorithm. So this is the most preferred when these two facts are fulfilled, right? So well, what is the algorithm for doing this, right? So what you do is you essentially start with the source vertex I, and then you initialize the distance for the distance value of vertex I to 0 and every other vertex to infinity. It essentially, why do you give it infinity? It's just that we assume that the distance of that other vertex is very far, and we assume that it is infinity, right? Then what do? Then we update the distance value of the neighboring vertex of vertex I. So whichever is the neighboring vertex from the vertex I, we update its edge weight values. So it's edge weights, right? So that's what we do. And every time a new vertex is visited, update the minimum distance value of its neighbors, right? So that's what we do, right? So this is the primarily algorithms, though even I think it's very easy to understand in itself, but let's take one example and understand this. So I assume that you already know this. So on the basis of that, this is similar type questions which is there in your graded assignment. So I have just taken out that kind of question here. So now look at this question. An undirected weighted graph G is shown below. Okay. Find the set of all positive integer values of x such that if we use the Dijkstra algorithm, the length of the shortest path from the vertex A to vertex J is less than 13. Okay. So this is what we have to do. So well, you know how to find out Dijkstra. So this is just one, a question which has been asked, like you have to find out the value of x here, so using Dijkstra algorithm, and you have to make sure that the shortest path from vertex A to vertex J is less than 13. So which option among them is correct? So try to solve by yourself, okay, and give your response in the peer deck, not in the chat window. Okay. So maybe you can take some time. Let's say we'll give you some 3 minutes maybe.
Sir, but vertices are A, B, C, D, and the answer is in 1, 2, 3, 4, 5. So what is meaning?
Okay, but what do you have to find out? Look at this. Find the set of all positive integer values of x such that if we use the Dijkstra algorithm, then the length of the shortest path from vertex A to J is less than 13. So it doesn't matter. We are not asking you vertices here. We are asking you what should be the possible values of x. It can be any values, but all you have to make sure that the shortest distance to reach from vertex A to J is less than 13. That's all. Okay. So try solving with the Dijkstra. Okay. As you are solving it, you will get to know what it is really been asked in this particular question. All of you, please solve. Then only you will be able to, learn from this session, because this session is like that. You have to solve with us and learn. I can see like 16 of you have already submitted the answers. Those who haven't joined yet, please join by going to joinpd.com. Just Google this and use this code LXRNIC. You will be able to participate. So do not put your answers in the chat window. Do any of you need more time?
Yes, sir, please.
Okay. So you can take another minute. So maybe we can discuss this now. Do any of you need more time? Okay, so whoever wants to discuss can raise your hand this particular question. Okay, Kaushal. Kaushal, can you unmute yourself? Kaushal Chaudhary. Okay, meanwhile he unmutes himself. Let's see what are the popular answers for this. So popular answer is B, even A and C, but not for D. Nobody opted for D. So, but popular answer is B. Okay. So if not Kaushal, Om Sharma.
Yes, sir. How to process this question? Can you explain first?
So okay, so basically I wanted those how to
Sir.
process. Did you solve this particular question? Oh,
No, sir, not able to solve it.
okay, fine. So fine, we'll discuss this in a while. How to solve this. Meanwhile, who was that other person? Kaushal.
Sir, without applying Dijkstra, can we approach in this way? Like for shortest path to J, we are seeing the incoming edges of J. So like J is incoming edges from H only. So we are taking as H from J 1 unit. And what is the shortest path to H is from G or E. So that will be either for J we can go for 3 or 5 units. Then from A to B, it is just 2 units. So total will be 7 or 2, 1, 3, 4, 6 unit. So we are clearly seeing that A from A to B, and then here E to G and G to H, then H to J will be a shortest path. So the overall so 6 plus X will be the minimum weightage for reaching A to J. So then for X plus 6 will be less than 13. So X will be less than 7. So the value will be 1, 2, 3, 4, 5, 6.
That is one way of looking at it. Well,
Yes, sir,
that's
yes, sir.
fine.
Yes, sir.
That is okay. But again, like it can go trickier here when, like when you change the edge weights
Yeah,
from,
yes, sir, yes, sir.
yeah, so it'll be trickier. Over here, you don't had any confusions like that. So of course you can say that.
But
Yeah.
sir, if we perform Dijkstra,
Doable.
like I have done it, so then, sir, we have to consider X for each and every time we are exploring after E, right? I mean, after
No, just forget when you are taking Dijkstra, just forget about this X factor.
Okay,
And see the other length and then check out, like, which is giving you the least value. Whichever gives you the least one, all you have to make sure is, I would say from B to E, what are the possible ways to go?
Yes, sir. So that's how I approach the B to E.
Simple,
That's
simple. You don't really have to think like, from A to J or whatever. From B to E, if you want to go, which is the possible way to go? This is
That is B to
ACE, which is
yes.
7, which is taking you 7 units.
7.
Or you can also go to A, C, H, and E, which is again giving you what, like 16.
Yes, sir, yes.
16. So which is giving you 7. So of course this is giving you the least. I mean, this is
Least,
giving
right.
you the least. So for this
So
X,
X will be less than 7.
7. So this
Yes,
should
sir,
be
yes.
the easiest one, I would say.
So
Yes,
that's the way I did, sir.
Oh, okay, that's perfect. So yes, so maybe is there anyone else who want to give an explanation to this? Anybody else would like to discuss this? If not, Om, you understood what I just told?
Yes, sir. I did same way, but I was confused about this 1, 2, 3, 4, 5, 6, 7. What is this? But I am
Okay.
approaching this question in the same way.
Okay, fine. So you see that essentially what you have to make sure is X can take any values, right? But all we have to
Yes,
make
yes,
sure is it is lesser than 7. That's all,
yes,
right?
yes.
Yeah,
Okay.
that's it. Yes. Okay, so fine, let's formally discuss this, like what I have in the solution. So when you want to approach this particular question, all we have to do is just assume that B is not there and then find out what is the shortest distance. Then how do we do? Remember, like we discussed Dijkstra algorithm. So I'll tell you like how we will follow the algorithm which is given and then discuss this particular question. Well, that's the smart way of doing it, what I told you, or like even you told. So that is completely okay for your examination point of view. But of course, like how is this algorithm working? Let's
Excuse me, sir.
discuss that.
Will you please repeat that shortest path once, sir?
This 7, 3, this thing, is it? Okay, I'll come to this. I'll
Yes,
come to
sir.
this part again. I'll come to this, but let me just go it in algorithmic way so that, you will have the other picture of it as well.
Okay, sir. Okay, sir.
Okay, so when you want to approach this particular question, first of all, forget about this X and think which is the shortest path to reach J from A. Okay, so how do you do that? So first step is forget about the edge BE, which is giving you X units, right? X unit weights. So now we'll start our algorithm from step 2. So what do? You initialize the distance value 0 to vertex A and infinity to all other vertices in the graph, right? So that's what algorithm says. Like, what is the initialization state? Whichever is your source vertex, give it a value 0, and rest other you say that it is infinite.
Sir, your voice is low, sir.
Okay, and now it should be fine, I guess. It's fine.
Yes, sir. Yes.
So, and essentially what you say is like you initialize the value to 0, and then you think of the other vertices from the source vertex is very far, and you assign the value infinity, right? So that's what your initialization step is. Then what you do is, so this is what it is done. You can see the vertex A is assigned with 0 and the rest other vertices is assigned with infinity. And we forgot that there is no any edge between B and E, right? That was something like X units, right? So something we forgot for time being. Let's say that is not there at all. Now what you do is, Now using this Dijkstra algorithm, update the distance value for each vertex in the graph that are adjacent to A. So why A? Because that's our source vertex, right? And whichever is the shortest distance from the vertex A in terms of weight, so you'll just have to update that. Now you see this, from A, you can go to B and you can go to D, right? So which is shortest over here? The shortest is D, right? So, and what is the weight edge for this? What is the edge weight? It's 1. So you will
1,
update
sir.
that distance. So why, which is minimum? Infinity is minimum or 1 is minimum? 1 is minimum, right? That is why it is been updated to 1. Okay. Now from D, you will go to B, or like, let's say you can go from A to B also, but whichever is giving you minimum, that should be updated. Now, what is the next minimum value to reach B? Is it 1 plus 5, 6, or 0 plus 2?
2, sir.
2.
A to
So
B,
you
0
will
plus
update to be 2, right? That's what you will do in the next step. So you see that you could have actually gone from D to B, but that would have given you distance of how much? I mean, that would have given the edge weight as 6, but that's not minimum. To go to B, you can also go from 0 plus 2, which is 2, and whichever is minimum, that has been updated here, right? Likewise, now if you want to go to C, the only way to go to C is from B, right? So it is definitely going to be 4 plus 2, right? And that's going to be 6, right?
Correct.
Now from here, from C, you can go to either E or H, right? So which is giving you the shortest edge weight. So now 6 plus 3 is 9, and 6 plus 8 is
14.
14. So which will be the next edge that you will be visiting?
E.
Right? So you will update this E.
6 plus 3.
So now from E, where are you going? From E, you will go to, you can go to 3 places, right? But whichever is the minimum one, you will choose that. So it will be 9
One.
plus 4, which is giving you 13, 9 plus 1, 10, and
10.
9 plus 6, 15. So of course, you will
10.
visit G.
10.
So that will be
G.
updated to 10, right? Now you can go to from G, I mean, and from E or like from C, you can go to, you have to look which is the minimum one, right? So from G, if you go to H, it gives you 12. And from G, if you go to F, it gives you 12 again. From E, if you go to F, it gives you 15, right? And also from E to H, it takes you how much? 13. So definitely you'll be visiting which edge? F, which is giving you 12, right? And from where you are visiting? From G, right? Right?
Right.
Yes, sir.
So that's how the F has been updated. And you see that even H has been updated simultaneously because it takes the same edge weights altogether, right? So it's 10 plus 2, 12, and 10 plus 2, 12. So if you would have seen the sir's lecture, you would have noticed that sir was talking about, you know, the tanks and the fire problem, right?
Yes, sir.
Right. So it's very similar.
Yes, sir.
So you can assume this, the vertices to be let's say oil tank, and this is just a pipeline, right? So you can think of that H is burning at the same time as F, right? So both has been colored here, right? Now of course, where do we have to go? We have to go to J, right? So
J.
of course, so it's a direct path from here, which tells you what? 13. Now, one way of looking at it is, now, of course, if I want to reach from 0 to J, and of course, from H, I can reach I also with the same 13. So that has also been covered here in the red. Now you see that there are two ways of looking at it, right? Now I understood that from vertex A to J, if I want to reach, what is the distance I'm covering? 13, right? That means if I choose the other path, like let's say if I have to go through BE, right? I have to make sure that I'm going with the 13 weights, and in the question it's already mentioned
Less
that
than
it is
13,
13. Yeah, it
Less than
should be less than 13.
Yes.
So definitely I have to make sure that if I'm going through this, then it has to be lesser than 13. Then what are those values that I have to choose, like look for?
Less
Right?
than 7, sir. It has to be.
So how do we actually conclude that is, of course, how am I going from here to from there to here is like, this is the path I'm taking, right? From here till here and here, like definitely I have to come till I have to cover this weight 2, right? Then from 2 I have to definitely reach either 6 or E, right? Right? But no, but I have to, if I have to go to J, right? The other path, the one path is going from, maybe I'll just show you the other slide. Yes, the other path you can see that which is mentioned in the green, this is the path I'll be taking, right? To reach from A to J, isn't it? But I have to minimize this altogether, right?
But
And I
it
have
is
to make sure
13,
that it is lesser than 13. Then
13.
what should I do is I have to just cut short this green path, which is B to C and C to E, right? So what is the distance of this? This is actually 7. So I have
7.
to make sure that from B to E, I cover lesser than 7,
Lesser than
right?
7. That is 6.
Which is 1, which could be either 1, 2, 3, 4, 5 or
6.
right? So that is something we can do, right? So now this would be the shortest path. Now you can see that A, B, X should be lesser than 7, E, G, H, J, right? So this is the path you have to cover, right? So I hope you understood now. For those who asked me in the very beginning, like what was the shortest thing? So now you understood why did we choose 4 plus 3 has to be lesser than, I mean the 7, X has to be lesser than 7. You
Yes,
got
sir.
that?
Yes, sir.
Okay.
Sir, in yesterday's class also, Subhashi sir also explained this one through
He
metric.
explained it. Okay,
Yes,
fine.
sir.
Okay, fine. That's perfectly fine. Okay. Then.
Sir, I
Okay.
want to ask one thing. This solution. Generally, I use that matrix. So in the matrix form, I used to do this, but it will take time to fill every vertex thing. So it will be easier way to solve this thing. I mean, how could I do this in the just like you picture, you just write this thing, but in exam,
You know what? I would suggest you whenever you get a matrix, first draw the graph for that matrix, whatever the matrix is given, because that will become very easy for you, because when the graph is given, you can visualize things and do it fast. You cannot think much in the matrix form, right? So whenever a question which is given on matrix, if you can bring it in the graph form, that becomes very easy. So you just take not much time, but at least you will get the clear answers from there once the graph is made. Okay. So make a practice of that. Yes.
Okay.
Okay. So now the next question is, so here is the question. A company has, so this is, you can think of which algorithm to be used here, but just think of it like you yourself can tell me as a hint, and we can go ahead with the question. A company has branches in each of 5 cities, which is mentioned as C0, C1 up to C4, right? So these are the cities. So these are 5 cities. The fare in thousands of rupees for a direct flight from CI to CJ is given by ijth entry of the following matrix. Now infinity indicates that there is no direct flight. Okay. So now an employee of that company want to travel from city C0 to city C3. Okay. If she traveled by the cheapest route possible, then the total fare in rupees she paid for the flight journey was. Okay. So now this is the particular question. Could you actually give me can you give me a hint, like which algorithm you will be using?
Dijkstra's.
Dijkstra's. So yes, you will be using Dijkstra's, but now here the matrix is given. So just a while ago, I told you whenever a matrix is given, just try to draw the graph for that. Okay. And then as you yourself told, the Dijkstra to be used. So Dijkstra gives you what? The shortest path from the source vertex, right, to every other vertices, right? And what is the only condition? That the edge weight should not be negative. That's all, right? So Dijkstra fulfills all the conditions. So I mean, it fulfills all the condition for the Dijkstra algorithm, so that can be used over here. So all you have to do is you have to find out the shortest path from C0 to C3, and whatever the value you get, just multiply with the if you get, let's say, you just have to multiply with the 1000 and enter the value, right? So let's see what are the responses. So maybe I'll give you 3 minutes for this particular question, 3 to 5 minutes. Let's see, and we can discuss this. So try to solve this question, because this is, you can expect like similar questions, or you just have to keep practicing, like, and let's say if you have been given 5 minutes and this question is there in the exam, then how do you really solve it? So think that you're in your exam and you're actually giving this. Okay. And over here you have a freedom to discuss, but in exam you will not have. So but just for the practice,
Hello, sir. Hello.
Yeah. Yeah, hi. Am I audible? Yeah.
Yes, sir. Audible, sir.
Yeah, please tell me. All of you try to solve this particular question. You can see only 15 responses now. And those who haven't joined yet can still join. Go to joinpd.com and use this code LXRNIC. You'll be able to participate here. Do you need some more time?
Yes,
Yes,
sir.
sir. Yes, sir.
Okay, so take one more minute.
Sir, the reason why we have selected Dijkstra algorithm is because it is a single source vertex and the edges are positive. Is that the right reason?
Correct.
Okay.
Yeah. So do you need some more time? Anybody? Okay. So assuming that you don't need more time, let's go see what are the responses for this. So many of you are giving answer as 6,000. So let's see. So would anybody like to discuss this particular question?
Me, sir.
Himanshu Dikshit, yes.
Okay. So, from C0, we have only two vertices, namely C1 and C4. And both of them, they are having weights like 2 and 4.
Okay,
So
Himanshu,
Yes,
first
sir.
tell me, like, what did you do from this step by step? Like, you have this matrix given to you. So how did you use this matrix? Did you drew the graph first?
No, sir. No.
Okay,
No
you
need
didn't
to
drew the
draw.
graph. Okay, so how did you go ahead?
Sir, I just looked at data. From C0, we have two edges, which are connected by weights 2 and 4. So I opt for the least one, that is 2, and it goes to the C1 vertex. From C1, I opt for the lowest weight, that is 3, and it belongs to the vertex C2. And from C2, I got to the C3, that weight is 1. So I added up all these elements, 2 plus 3 plus 1, it is 6,000
Yeah.
answer.
Yeah, that is also perfectly fine. So, well, this was very straightforward. I mean, looking at the matrix, you can definitely say this. That is perfectly fine, Himanshu. Maybe that shows that you have a hold on this particular question. So that's perfectly fine. But for all others, the safest and the even I cannot.
Sir, I have gone for the graph, sir.
I have done
Okay.
for the diagram, sir.
Okay, so yeah, fine. So would you like to discuss, Vishwajit?
Yes, sir.
Yeah.
So the diagram will be, we will going to take a
So
draw
this is
diagram.
what, something like this you get?
Yeah.
Yes,
Something
sir.
like that.
Yes,
sir.
sir.
I have done.
Okay.
So from C, two branches will go. One branch
Okay.
is go to C1 and C4. So C1, it will go to 2, sir. Distance will be 2. And for C0 to C4, it will go 4. And then from C1, two branches will go out. One is to C2 and one is C3. So C1, C2 will going to be 3, and from C1 to C3 it will 9. And to then from C2, two branches will go. One is to C2, C3 and C1. So C2 to C3 will be 1, and then C2 to C4 it will go to 5, sir. So I did that.
Okay, nice. So yeah, so over here, see, that is perfectly fine here. I think Himanshu was able to figure out just by the matrix, he was able to do it. But essentially, what he was doing is he was actually visualizing this graph and he was actually thinking it like, okay, this could have been like from here to here, from C0 to C1. If you have to go, of course, it is connected here. That's why it is 2. And then he gone with the least one and then he gave the answer. That's fine. I mean, you need more practice for doing that kind of things.
But sir, if in here is C4 and C2, the cost are reversed. I mean, C1 will be 4 and C4 will be 2. Then we have to consider both the vertices, not the least. Because from C4 we go C3, then cost
right,
and then we have to check all the C2 also.
Right. So that is definitely right. And something could have been done here. Like if the vertices were increased, then it would have been more difficult. Just looking at the matrix and giving the answer. So in that particular case, in all the cases, I would suggest you to first draw the graph and then figure out which algorithm that you have to use. I mean, you can essentially get it before, like which algorithm you have to use, but the graphs makes the things easy. That's what I would say. So okay, fine. So now we have the graph of this matrix, right? So do any of you have doubt how to create a graph from this particular matrix?
Yeah, sir. Please, can you explain?
Okay. So now you see this. I hope you understand this. Rows. This matrix graphs consist of rows and columns, right? So these are like these are the rows and these are the columns, right? So now you see this, wherever from you see that C0 to wherever you get this infinity, let's say C0 to C0, it's basically it's somehow connected, and like you just assign the value to itself. Is like, since this is a diagonal element, you give it as a 0. C0 to C1, now you see that it is connected. C0 to C1 is connected. And what is its weight for that edge? It is 2. So let's say C0 to C1 is connected and its value is 2, right? Likewise, C0 to C2. C0 to C2 is not directly connected and therefore it is given as infinity. That means there is no edge, right? Similarly, C0 to C3, it is not it is not connected is just because the value is infinity, right?
Correct.
Similarly, C0 to C4, it is connected, and what is the value?
4.
Right? So if you studied the adjacency matrix, like in the previous week, you would have seen that in adjacency matrix, what was the edge weights we were giving if they were connected? 1, right? And if they were not connected, what was the value we were giving?
0.
Infinity. Sorry, yeah, 0, not infinity. So over here, it's just the, you can say the, maybe you can say that the advanced version of that, wherein we are actually using the edge weights concept here. So if they have an edge and whatever the corresponding weight is, that is something we are writing in that matrix. So understood. So if they have been given any weights over there, some weights is given, that means they are connected. And once they are connected, and then what is the weight of that edge is also mentioned in this matrix. Okay, so this is how you can actually build the matrix.
How do you look at C1 to C1, C1, 0? Okay, they have either given 0 for the same point, or there is a weight, or infinity. So
Right.
0 and infinity are different here. Okay.
Yeah. Okay.
So once you draw the weight, if you could just help the solution with that algorithm once more. Yeah.
Sir, this diagram could be a little bit, heavy. You can draw the way I did the diagram, sir.
Okay, so yeah, of course, everybody would have got it like different ways of doing this. So one of the ways here, yeah, that is perfectly fine. It's okay.
So now the shortest distance would be from C0 to C3. So
I'll discuss that.
Okay.
Yeah. So now what you will do, you will use the Dijkstra algorithm, right? From where we had to reach from C0 to C3, right? So now how do we reach? Now, of course, the algorithm says what? First initialize it. Initialize the source vertex to 0 and every other vertices to infinity. And then you find, what do you do then?
Then you find the shortest path.
Shortest path to the neighboring vertices. So then you go to the which vertex? C1 or C4?
C1.
So why do you go for C1? Because that is the shortest distance, right? So you go for C1 and then you update that C1 to 2. Now from C1, where do you go?
You can go to C2 or you can go to C3, but you will go to C2 because the distance is shortest.
Perfect. So that is something we update.
It's 5.
Okay, wait, but you could also go to, look
C2.
at this, from C0 to, you can actually go to C4 also.
Correct.
Because you see this, from C1 to C3 takes you 5, but from C0 to C4 takes you what? Just 4. So you'll update that first. So you'll go with C4. Then
Then from C4 you'll take the next shortest distance, which is either C4 to C2.
C4 to C2 will take how much? 9. But C1 to C2 will take you 5. So that will be lesser time.
15.
Yes.
So we'll go with that. So you can see that we are going to C2, but from where we are going, I think the edge should have been highlighted, but it's not done here. So that's okay. But we understood how does this algorithm works, right? So likewise, from here, from C2, you can actually go to C3, right? And it takes what? 6.
6. Okay.
So altogether, you see that the shortest path from source vertex to every other vertices has been updated here, right? And you see that if you have to reach C3, then you have to go via C0 to C1, then C1 to C2,
and then C2 to C3.
C3, which is shown in the green path over here. So which is actually 6. And then as the hint was given, it's in 1,000. So it is actually 6,000. Yeah.
Right. So thank you.
Yeah, welcome. Thank you. So yes, so this is the answer. Now, a follow-up question on this.
Sir, one doubt there. In each of the row, if I select the minimum value, do I still get the same answer, or it will be wrong to approach that way?
Actually, I think Bishwajit, no, not Bishwajit, Himanshu did it with that method, which he got it right. Of course, you can do it that way, but it requires bit practice, and you really have to keep a count of it. Otherwise, even if you make a single count, then it goes wrong. So better to draw the graph and then do it, I would suggest.
Yes, sir.
It's safer. You can just practice and you can use matrices as well. But I would say this is safer. It doesn't take much time. You just have to draw it, and then it at least give you more chance of getting right. I would say even that would give you, but it requires more time. I mean, you require more practice. Okay. So
Because
for
sir,
this,
sometimes it will get wrong, sir. That's the reason you just draw a diagram according to this matrix. It will give you the correct answer.
yeah, you can do it both ways. Yes. Okay. So now the follow-up question on the same particular question. Now, if an inspection team wanted to inspect all the branches of the company, starting from C0 and ending at C3, visiting each branch exactly once, then which route should he choose in order to pay the minimum fare for flight journey? Okay, so now what? Here an inspection team wants to visit from C0 to C3, but inspection team also wants to make sure that he is visiting all other vertices, right? Then which is the path that he or she has to choose? Okay, so now you would notice this from in the previous one, you see this green color path from C0 to C3. The shortest path was, you see that you don't actually have to go to C4, right? But the inspection team has to make sure that in the next particular question that he has to visit all the vertices and reach C3, right? Then which is the shortest path? That is the next question. So you can actually solve this question, take another like 3 minutes and figure out what will be the thing and just write down, then just enter that which are the vertices in which order it has, I mean the inspection team has to go, and you can enter it in this way, which is written at the down. You can write down C0 comma C1 comma C2 like that, right? In the which order it is going. So just take maybe 3 minutes and try to solve this.
Hey, anyone knows like when was the last date? I mean, I'm just saying that this graded assignment 11, the last date is already over. But I think last time we discussed that it will be extended.
Yeah.
So the date was not extended.
No.
No, sir, it was not extended and it was done. We have submitted it yesterday.
Okay.
It was asked, but I think there was no confirmation on that. Sir had suggested, but I think there was no confirmation.
So for grading, like let's say I have not attempted that. So how they will take, like still best of 9, is it?
Yeah, best 5 out of 9.
12 out of 7 out of 12.
7 out of 12, no? Yeah.
Yes.
7 out of 12. Best 7 out of 12.
11, not 12.
Best 7 out of 11, correct.
7, okay. Okay.
That is for the 10% weightage on the final evaluation, right?
Yeah, that's what I'm asking.
Correct. Yeah.
Okay, missed it anyway, fine.
Okay, do any of you need more time to solve this? Should we go ahead?
We will go, sir.
You need some more time?
Yes, sir.
Done?
No, sir,
Okay.
done.
Done, sir.
All right. So let's see what are the popular responses for this. Okay, so C0, C1, C2, C4, C3. Okay. C0, C1, C2, C3. But what about C4? We didn't visit here. So, okay. Somebody is also saying C5. There is no C5 in this. C0, C1, C2, C4, C3. Well, this is the answer, but let's see. Even somebody says C0, C4, C2, C1, C3. Okay, let's see whether that could be right or wrong. Okay, fine. So we can just see that C0, C1, C4. So most of you are giving this as the answer. C0, C1, C2, C4, C3. Okay. C0, C4, C3, C2, C1. Okay. This is also an answer. Great. Let's see. Let's see this. Okay. So would anybody like to answer this?
Yes, sir.
Okay. Ahmed, right?
Yes, sir.
Yeah, Ahmed. Yeah. So what did you do for this?
So I
First of all,
made the
again.
graph. I did my graph.
Okay. Perfect. So this is the graph you get, right? After
Yes,
drawing
sir.
the graph.
Yes.
Okay, like similar type, at least not this, but similar type, right?
Yes.
Of course, your placement of vertices might be varying, but that's okay. Like roughly we get the graph like this.
Yes.
Okay, then what do you do?
I calculated the distance, and the two distances which I got was 20 and 21. 20 being the minimum, which was my answer C0 to C1, then to C2, then to C4, and then to C3. And the other one was 21. That's why we were asked to choose the minimum one. So the shortest distance was for.
Yeah, fine. That's perfectly fine, Ahmed. Thank you.
Yes,
so yeah,
thank you, sir.
so Ahmed, yeah. And to others also, you see this. And even in the response, I got like these were the responses like C0, C1, C2, and C4 to C3. Like this was the popular response. Yes, that is right. But also people were giving this as the answer: C0, C4, C2, C1, and C3. But you see this, once you do this part, like since inspector has to visit all the vertices, all you can do is like you can join all these vertices and then just count the weights all together, like which is giving you the minimum, right? So you can see this is the one way of going: C0 to C1, then C1 to C2, and then C2 to C4 and C3, right? This is the one way. What about going from this way and thinking about going this way and this way? So this would have also costed you more, right? So if you go this way, like for 14, 15, 16, 17, 18, and 18 plus 19, which is again 27. So that is the lengthiest I feel compared to the other path. So you can see that the green one is the green path. What you see is actually giving you the shortest path, right? So that is something we will consider and discard this red color path. So I hope this was here. It's just that you had to just give a practice to it on this vertices and the edge problem. That is all about this particular question.
Sir, this one from C2 to we can go to C3, right? Why you are not going to C3?
C2 to C3, yes, but inspection team has to make sure that it visits all the vertices. You can go to C3 and then what?
C3 to C4 is connected.
No, that's
According to question, sir,
C3 will be the last stop.
yes. C3 should be visited at the end.
Okay.
According to question, sir.
Yeah, that is as per the question. That's why. Okay.
Excuse me, sir. Are we just supposed to do this question by trial and error?
Yeah, it's just that you have to do it by trial and error, right? Okay.
Yes, sir.
Yeah. Okay. So now next is this minimum cost spanning tree. So could anybody tell me what is a tree?
Minimum optimal path.
Just what is a tree?
Minimum connected acyclic graph.
Minimum?
Minimally connected
Acyclic.
Minimally connected acyclic graph, right? So that's the definition of a tree, right? So what is a spanning tree?
Sir, it's a subgraph
Subset of
Subset of a graph where we can
N
divide
minus
the graph into different trees.
No, that is not.
Sir,
right.
sir,
Yeah, Vishwajit, please.
So actually, it's a subgraph of an undirected connected graph, like which includes all the vertices of the graph, with the minimum possible number of edges.
That is
with
that
N
is
minus 1
acceptable.
edges.
Okay, that is also accepted. But yes, all that you have to do here in the spanning tree is basically spanning tree is also a tree, or you can say it's basically a subgraph, which is a tree, and you have to make sure that you are including all the vertices of that graph G. Okay, so you can have a tree of a particular graph in which not all vertices are connected. You can have that tree, that is a tree, right? Let's say I have a graph with 5 vertices and I just connect 2 vertices, right? And say that this is a tree of this particular graph. So of course, it's basically a tree, it's basically a subgraph, right? But when is this a spanning tree? When all the vertices of that particular graph has been connected and it is minimally connected. So that graph is called as a spanning tree. Okay. So well, how is spanning tree different from a tree? You got to know. Spanning tree is a subgraph of a graph. That subgraph should be basically a tree and all the vertices are connected in that. Okay. Then what is the cost of a spanning tree? So what do you mean by cost of a spanning tree? So whatever that edge weights are. So whatever this subgraph you get, or whatever the spanning tree you get, so you just have to just measure the edges of those particular subgraph or the spanning tree. So whatever the sum you get altogether, that is the cost of that spanning tree. Okay, so we know that it is the sum of the weights of all the edges in the spanning tree. Well, then what is MCST? So MCST, as the name full form says, MCST is nothing but minimum cost spanning tree, right? So what do you mean by minimum? The name itself says what? Minimum cost spanning tree. So though you will have a various spanning tree, of course, a graph can have a various spanning tree, right? But whichever is whatever the graph you get, whichever is giving you the minimum cost, the spanning tree which is giving you the minimum cost is called as MCST. But then how do we find this MCST? So how do we find this MCST? So as you told in the beginning, we can do this via Prim's or Kruskal's algorithm, right? So these are the two ways. Now you see this is a particular graph G. You see how many possible spanning trees are, how many, you can see that there are 3 possible spanning trees, right? And let's say if I was assigning a weights for all these edges, then you will, if you want to find out the minimum cost spanning tree, so whichever was giving you the minimum cost, that would have been the minimum, that would have been the MCST. That is what we have to understand from here. So now let's go to the Prim's algorithm. So how is this Prim's algorithm performed? So I'll just tell you like how it is done, and we can just discuss this more. We are discussing a question. So Prim's algorithm is used for finding MCST, as you all know, of a given graph with n vertices. So how do you do this? You basically incrementally build the MCST of the graph. So basically a graph is given, and now you are building a tree And how are you doing? You are incrementally building it from the low cost to high cost. So that's what you do. So how do you do this? You first initialize. So here TV is basically a set. It's called as in tree vertices, and TE is nothing but tree edges. Okay. So this is a set. As you can see, it is a set. And what do? You initialize this set with empty set value, right? So it's basically an empty set initially, right? So then how do you add next? So in step 3, what do is you choose the minimum edge weight. That is, you will be given a graph, right? Then you will choose that particular edge which is giving you the minimum cost. Okay. So whichever is the minimum or the least edge weight, that is something you select at the beginning. And you mention that in TV, as TV is nothing but 3 vertices. So you can see that it is mentioned at I comma j. So you can be 2 vertices ij, and 3 edges is e. Basically this ij edge is nothing but your e, right? As you can see here on the top here written, right? So that is the thing. And then how do you build the tree? Then how do you build the tree? Then you go with the, then what do? You basically, how do you choose it? Like whatever is given in your tree vertices, like whichever vertices are there in your tree vertices set, from there you go to the next neighboring vertices, whichever is giving you the minimum cost, right? And that's how you build the tree. But you have to make sure that there is no formation of tree altogether. So that is what we have to make sure. So now look at this particular question, and I think this was Prim's was also discussed in the previous live session. So I assume that most of you know how to solve this. So here is a particular question to you. Consider a weighted graph G with 7 vertices, which is represented by the following adjacency matrix. If we perform a Prim's algorithm starting from the vertex R, now over here a matrix is given and it is mentioned at PQRST right? So these are the vertices. Now you have to perform a Prim's algorithm starting from the vertex R. Then the order in which the vertices will be added to your tree vertices set is. So you have to tell me in which order your tree vertices sets will be added. So you can just, mention that in the form of the letters separated by a comma. Okay, so that is something you can do. So maybe you can, again, how do you solve this particular question? So you see this.
Just we have to imagine that C0 to C1, C2, these are the vertices.
Right. So again, over here, this matrix is given.
PQR.
Right. So here, whatever the matrix is given, all you have to do is from this matrix, you have to draw the graph. And from the graph, you can actually find the, you can perform the Prim's algorithm and get the answer. Okay. So that's one hint. So try doing this. Take like 4 minutes maybe. So got some 3 responses till now. Is it done? Do you need some more time?
Done, sir.
Is there someone who needs more time?
Yes, sir.
Okay, fine. Take another minute. So I can see very less of you have given response till now. It's just 12 of you have given response. And we are like 50 plus here.
So one quick question. Spanning tree can be derived from both weighted and unweighted graphs, is it?
Spanning tree, right? Yes.
Okay.
But since here the cost is involved, right?
Understand. Okay,
right.
when it comes to cost, we need a weighted graph.
Right.
General spanning tree can be
Yes.
even from
Yes.
unweighted.
Yes.
Sir, does the concept of a spanning tree exist for a directed graph as well?
Basically, I don't think so. For time, I mean, you can say that, but this Prim's and Kruskal algorithm works for undirected graph. It may exist, you can say, but it'll be like, in a different way. I mean, it will not be the. Actually, you can say it can be in the modified version of this, but that concept is not there from our point of view for this particular course, I guess. But it could, you can actually think of, right? Like if there is an edge, you can actually, since we are actually studying this particular algorithm, that is why we are going with undirected graph. But when you don't have this algorithm altogether, then you have this freedom to actually think about, how will that be? How will that actually appear? So you can actually think of in that way. Okay.
Sir, provided it's not cyclic, right?
Again, that it depends, because you see, spanning tree, you are creating a tree, so it will essentially not have any, a cycle in them, right?
Yes, sir.
Right. So it's more like you are doing BFS and DFS, isn't it?
Yes,
Because in
sir.
BFS and DFS, again, all the edges are connected and it's not a tree, right?
Okay, sir.
Yeah. Okay, so let's go with the popular responses now. So people say RUVPQST. Okay, so most of you are giving this as answer. RUVPQST. Okay.
So your voice is a bit low now.
Okay, sorry. So RUV PQ ST is like the most popular response. So let's see how is that. So would anybody like to answer this?
Yes, sir.
Okay. So Vinay, right?
Yeah.
Yes, Vinay. So what did you do can you tell me the steps first? Then we can go in details. Like you have been given a matrix.
Okay,
So
basically we try to draw a graph, undirected graph, a weighted undirected graph from the matrix.
Okay. Okay. So you
Okay.
get something like this. Okay. Let's say you get something like this.
That's similar to this. Yes.
Hmm.
And as Prim's algorithm says, right, we starting from the vertex, we start exploring the minimum edges for its neighbors. So when I take R, right, so the minimum weighted edge of a neighbor is U. So we consider U there. And then once I reach U, I look for the next vertex. So I will consider now the neighbors of both R and U. So since from R to V it is 3, now I consider it as V.
Yes.
So likewise, now we don't have any edges for U and V. No, I go to V, and from there I go to P. So I bring P in our TV. I'll then from P, I consider either Q or T. So since Q has a minimum edge, I add Q to the TV. Right. And from Q, I consider S because the edge from Q's neighbor and P's neighbor is 8 and 9. So instead of PT, I consider QS. And from there, I go to ST, sir.
Okay. Yeah. Yeah, that's actually you followed the Prim's algorithm and gave the answer. Yeah, that's perfectly fine. Vinay, thank you.
Yes,
Okay.
here I do only simply.
Sorry, what?
I follow the same method, but here, here I just consider the weight of the path, which will age of weight of the age is minimum. I choose that.
Okay.
Like that. Is it correct method? No, just
That is correct, but
okay.
that is correct only. But you have to make sure that whichever vertices comes in your tree vertices, and from considering that vertices, you explore the neighboring vertices, making sure that the next edge weight is minimum. That is what you will have to do.
Sir, one doubt there. So at any point, let's say when at any given vertex, when we select the next move, so we have to just select the minimum weight, right? It is not that in the second move, like addition of the first move and second move, maybe the other path will give the shortest, but we don't go that way. We just select the immediate move, which is the minimum. Once we make such move, we don't think that previous move what was right or wrong. For the next move, again, we decide from here what is the next minimum.
Right.
Okay.
But you will have to choose, but whichever your tree vertices comes, right? It can be minimum from any of those vertices. Need not be that the next the previous vertices you will have to consider. Okay. It need not be that.
Yeah. Okay. Yeah. Okay.
Yeah.
Sir.
Yes.
So when we select first of all, sir, Q, then R, then B, the method is wrong.
From Q, no. Why will you choose Q?
We just start from Q, sir.
Why? No, that is actually wrong because your Prim's algorithm says that you will have to choose that particular edge, which is of minimum edge weight. So which is minimum edge weight edge? UR.
Yes, sir.
Yes. So, but again, in this particular question, it was told that start from vertex R.
Okay.
So it's just to initialize one vertex. It was being told, right? So now, how do we actually do this? When you do the Prim's algorithm, let's discuss how this algorithm works. So TV, as I told you, this is a set, right? And T is also a set. You initialize this set to 0 value. Basically, it's a null set, right? And in this particular question, it says that starts from the vertex R. So now your TV. Now TV is what? Tree vertices. So which vertex is entering into this set? R. So when the R comes, still you see that T is empty still, right? So in the next step, from R, you will have to choose the next vertex, which is giving you the minimum edge weight. So you can go to U. right? And you can go to V, but which is giving you minimum? UR, right? So you will select this UR edge. So you see this, you select this RU edge, and then next this U vertices comes into TV. Now look at this. Now you are free to use any of these vertices. Like you can either use U or R vertices to reach any other vertices, which is of minimum cost, right? So you see that from U, if you go to V, it costs you how much? It costs you 5, right? But if you go from R, it costs you 3. So you will go from this, right? So next edge which you will select is RV, right? So next RV comes into your TE list, that is tree edges list. And which is the next vertices comes in the list? TV set, which is V, right? So now again, now you can consider any of these vertices, either U or V, to explore the next vertices, but you have to make sure that there is no cycle formation, right? So now you could have actually told that, yes, why can't we take this, right? UV edge. But again, when you take this creates a cycle, so you will not be taking this, right? So then what? You can choose the other vertices which is not explored from the any of these vertices. So which is that? VP, right? Which cost you how much? 7. So
7.
You are forced to take that. So yes, that is something you will take. VP comes in the list, and this P enters your TV list, right? And then from P, where all you can go? You can go to Q and you can go to T. Basically, not just P, you can check any other vertices, but you are not able to go to any other edges. That is why these are undisturbed. These are kept as it is, right? So from P, you are exploring to other things. So where you go next? You can either go to Q or you can go to T. So which you will choose? We'll go to Q. So that is why PQ comes in the next list, and Q vertices is been comes under TV. Now from here, from P you can go to S, from P you can go to T, which is costing you less. You can see that if had it been this as a 7, right? If this was 7, let's say instead of 9, it was 7, you would have gone from which edge would have come next? PT would have come next.
Yeah.
Okay. So this is one thing that we have to understand. But over here, since QS is there, which is of minimum edge weight, so that is something you will select. So QS enters your TE set, and S is the next edge that enters your TV. Now from this you can go to T. Now you see this again, you can go to T either from S or P, right? So you will choose ST because this is giving you the minimum cost, and that ST enters the TE list, TE set, and then T is also enters your TV set. So this is something you get at the end. So now finally your TV set is updated and TE set is also updated, as you can see, right? So all of you are clear with this?
Yes, sir. You explained about if PT would have been 7. Can you just explain that? I just missed.
Right. So now you see this. I was at that particular step. PT, right? So, so now you see this. Now let's say your TE edge we are updating, right? Now let's say you have explored. Now you have come to this Q edge, right? Let's say if instead of 9, this was 7. You understand this? You can see my cursor?
Yeah.
So instead of 9, if it was 7, see after P, your next entry was Q, right? Q entered your TV set, right?
Correct.
Now, if you want to select the next vertices, it is not mandatory that you will go with the Q. You can choose any of these vertices, but you see this, you can actually take P because this was giving you a minimum cost, that is 7. So the PT set would have, PT edge would have entered your TE set, and T would have entered your TV set, not the S at that point of time. Okay.
No, but it is PQ is 6 and PT would be 7. So how will it?
No. Q is already entered your TV. That is what I'm saying. Yeah.
Okay. From 6, 6 from QS, instead of QS, you'll say there will be 7 plus 2, 9, and this will be 8 plus 2, 10. Okay. That way? Yeah.
Right?
Okay. Thanks.
Okay.
Sir, I got one observation. The way I was doing it, and I found the answers are coming more or less okay, whatever I practice.
Okay.
For I identify 2 cycles here and break the cycle with the maximum weight and take that out. So that was giving the right answers. Like
even that is perfectly fine.
That is okay, right? I mean, rather
Yeah,
than
that is
doing-
also, it's more like you are doing Kruskals.
yeah, with ascending order.
Yes. It's more like you are doing Kruskals. Yes.
Right.
Okay, that is also fine. Okay, fine. So let's go to the next algorithm, that is Kruskal's algorithm. So in Kruskal algorithm, what do we do? Again, we find MCST. So there are two ways of doing it. So one we learned already, Prim's algorithm. The other is Kruskal. So if in your exam, if it is asked to find out MCST, you can use any of this algorithm to get the answer. Okay. So how do you do this? Is you basically create another set E. So this E set contains an edges, the list of edges which is mentioned in an ascending order. So basically from the least edge weight to the most edge weight. So that is something arranged in this order, this set E. Okay. So now what you do is you select your tree edges, and you select your tree edges. You first initialize it to an empty set, and then you start upgrading it. So you select now over here in this set E, you can see this E0. E0 is basically an edge. E1 is also an edge. E2 is also an edge, and M comma 1 is also M minus 1 is also an edge. And how is this been arranged? In an ascending order. Now from when you're building your Kruskal's algorithm, what do you do is whichever is the least tree, the edge, whichever the least weight edge, that is something enters your TE. So of course this is mentioned in an ascending order. So you select E1, right? Sorry, E0, right? So from E0 you start building your tree. So you select the next edge in such a way that there is no tree formation. So basically there is no cycle formation. So now let's say that from E0, now you will definitely choose E1, but all you have to make sure is that E0 to E1 is not creating any cycle, right? If it is not creating any cycle, then this enters your TE set, right? And from E1, you can actually choose E2, but again, you have to make sure that again, there is no cycle formation. This is all that is needed for Kruskal's algorithm. So likewise, again here, the same particular question. Now you have to perform a Kruskal's algorithm to get the answer. So maybe you can take another 3 minutes and try solving this particular question.
Sir, one generic question. Hello?
Yeah, hello. Am I audible?
Yes, sir.
Yeah.
So if they ask a question like multiple select question, right? Say for example, BFS can be used to identify farthest or the farthest vertex. Is that a right? Is that a true or false, sir? Because I generally, from a lecturer, what I understood is like we use BFS to find the shortest path for a vertex and DFS for the longest path. So if they ask a question like BFS can be used to find the farthest path for a vertex, is that true or false, sir?
BFS. You're talking about BFS.
Yeah, BFS, you're right.
See, it again depends, right? So basically, what you do in first, let's start with DFS. DFS is something you do that depth first search, right? So,
yes.
So you basically find out whichever. I mean, you get so many trees. Let's say you got some 3-4 trees or something. 3-4 branches, let's say, right?
Okay.
So
Yeah.
of course you can say that from here this is the farthest branch, right?
Correct.
That is something you get, but that is actually not the actual application of BFS and DFS, I would say. Right? For that you can actually use topological sequencing, right? Or like the longest path using your DAG, right? Maybe you can use that.
Okay. So
right?
there was a
Instead of
question. Yes, there was a question activity or a practice exam where I didn't select like BFS can be used for fathers, but that seems to be a right answer. So I was not able to comprehend how that is a right answer. So that's why I asked this question.
Okay. Okay, maybe even I don't know this right now.
Okay, right.
Okay, fine. Maybe just let me look into it.
Okay, sir. It is in week 10 practice question 7, sir. But I'm not sure how it is a correct answer. So that's why I asked this question.
Okay, fine. Fine. Since you see in BFS, actually you go layer by layer, right? So again, you can actually say that since you are going layer by layer, so that could actually be thought of.
But still, that is
But
shorter.
again, let me think about it.
Okay.
I'm not able to comprehend it right away.
Okay,
Yeah.
sir. Fine.
Okay, yeah. Fine. Let me think about it, and maybe you can put it in the forum or like wherever. I'll answer it there. Okay.
Okay, I think I've done it. Okay, I'll do that again, sir. Yeah.
Okay, fine. Yeah, thanks. Okay, so do any of you need more time for solving this, or it's done?
Just a few minutes.
Okay, it's fine. Take a minute again. So. Okay, so shall we discuss this now? Okay, so I request those who want to discuss this can raise your hand. Okay, apart from Ahmed, anybody else? Okay, fine. So maybe Ahmed, you yourself can tell this. So okay, Neha, maybe Neha Vishwakarma. So yes, first let's see what are the popular responses for this. So are you ST, VR, PQ, PV, QS? Are you RV, VP, PQ, ST, okay. RU, ST, VP, QS. Okay, so this something I can see that the first one is something been repeated again and again. So most of you are giving that as an answer. So let's see what is the answer. So yeah, so maybe Neha Vishwakarma. Neha, can you unmute yourself? Okay, fine. So Subhashri.
Yeah, yes.
Yes.
Yeah. So can you just show the graph?
Yeah, sure. So yes, so this is what we get. It's basically similar to the previous one.
Yeah, so yes, so it's very similar to the previous one. Yeah, by Dijkstra's algorithm, so we will be making the graph based on the weightage. So we will be ordering the weights of the edges first. So based on that, we will be making that path. So out of this graph, so RU is having the lowest weight, or that edge is having the lowest weight. So first we are making it as RU. Then after that it is 2. So it is from SP. Then after that again it is 3. It has been made between R and B. Then it is, so the next one is 5. So since we have this R, U and B are connected already, we are not using this 5 now. So after that it is 6. So then we are taking that PQ, and again.
Okay. Subhashri, just a minute. So first of all, what we are doing is we are writing, let's say, a set E, which contains all the edges in ascending order, right, Subhashri? This is first we'll do. Like as per algorithm, we will just write all the edges in its ascending order of weights, right? And from there, as you are telling it, just select all those weights, but you have to select in such a way that there is no cycle formation, right?
Yes.
Yes, yes. Please go ahead. Please go ahead. Yeah.
Yeah. So we have to select the edges which is not forming the cycle, and which is not the vertices which is not being yeah. Then yeah, I was there here. So we were just selecting the edge which is Q and P, so which is having the weight as 6, and after that we have the edges P and V, so which is not forming a cycle. So again it is, we are selecting that one. Then we have that order as Q and S, so that one we are selecting, and after that we are just making it with P and T.
Okay. Okay, fine. Yeah, that's perfectly right, Subhashri. Yeah. So all we have to know is just the approach for solving this. So Kruskal is all about you arranging all the edge weights in an ascending order as it is done in step 2, you can see. And from there you select all those edges with the minimum edge weights. And whenever you pick the edges, you have to make sure that there is no there is no cycle formation, right, Subhashri?
Yeah, yes, sir.
Right. So thank you. So what, as per, now I'll just discuss as per the thing. So here what are we building is we are building the tree edges and we initialize that to empty set. Now scan all the edges starting from edge RU, right? Now start adding the edges in TE and build MCST. That is the algorithm which is told, right? So now in your tree edges, now you select this RU. So as you can see, this RU is selected here and that enters your tree edge. Then from RU you select ST. So as you can see here, so from RU, ST is being chosen because that was the next minimum edge weight it was. So that is something being chosen. Now, and there is no cycle formation when I'm using this ST. And also note that I am least bothered about connecting those vertices, right? Unlike the Prim's algorithm where I had to make sure that, when I'm going to the next stage, I have to make sure that the edges are the neighbor of already existing vertices in your tree vertices, right? That is what we were making sure. But over here, that's nothing like that. All you had to do was arrange all the edges in an ascending order and then start picking it up in your tree edges, right? And only thing that we have to make sure is it is not forming any cycle. That's all. So now next you choose RV. But when you choose RV, so where is RV? So RV, as we can see here, RV is here. So RV will again not form any cycle. So that enters your tree edges, as you can see here. Then next you select what? UV. But again, let's see UV, where is it? Here. So when we select UV, note what does it happens. When you select UV, it forms a cycle, right? So that is something we will not do, right? So that will not enter this cycle. So essentially this is something like somebody was discussed, I forgot his name, but he was telling, right, all we had to make sure that there is no cycle formation and just select the minimum weights, that's all. So that was more like Kruskal's, right? So now when you select PQ, now look at this PQ, where is it? It's here, right? So it will not create any cycle, so that will enter your TE. Likewise, next we will check for PV. PV is again PV, right? So PV is again not creating any cycle, so that enters your TE. And then at the end, so you will go with QS. Now is QS creating any cycle? So again, it's not creating any cycle, so that's entered your TE set, and finally you get this. So I hope you understood this. Okay, so assuming that you understood, we'll go to the next algorithm. So this is what finally you get, right? So fine. So I hope this is okay. You understood this Kruskal's algorithm. So the next is, yeah, any doubt over here? No doubt?
No, sir.
Okay, so now you see this. Next is Bellman-Ford. I think this was discussed in the previous session and the same slide was used over there. So I'm not discussing that here. And it actually takes
Sir,
time. So
can you please explain this thing? I missed yesterday's class and this is very complicated thing. I'm not able to get it.
So you can actually see that video again, because it will take, if I explain this, it will, it'll actually take a lot of time.
Okay.
So what I can do is rather I can discuss Floyd-Warshall algorithm, right?
Yes.
So that is something I can go with. Okay. So let me just take you directly to Floyd-Warshall algorithm. So you see this, what do you do in Floyd-Warshall algorithm? We compute all pair shortest path. Okay. So it is all pair shortest path. Unlike the Bellman-Ford or the Dijkstra algorithm, where you had the source vertex, right? Over here, you don't have anything called source vertex, but you are finding all pair shortest path. Okay. So this is like more powerful algorithm, I believe. So what are some facts or what are some things that you have to keep it in your mind while you're using Floyd-Warshall algorithm? First of all, it is applicable for directed, weighted graph for both negative and positive edge weights. Okay. And it is not applicable for the graphs having negative weight cycles, right? So these are the two facts that we have to consider. So how does this algorithm works? Well, I'll come to this algorithm part later on, but or later onward, I'll basically explain you when I'm just telling you that how it is done. So what we do essentially is, now I'll just give you an example and discuss this algorithm. It will be difficult for me to just tell you algorithm without any example. So I'll just show you an example and discuss this algorithm. Okay. So you would, but all I want you to tell is here, this SPK, shortest path, this K is written, right? So this K indicates that shortest path via this vertices. If it is like SP5, so it means that shortest path via vertices 5. That means you can actually go to vertex 0, 1, 2, 3, 4. So SPK means up to K minus 1. So essentially 4. So you can go to any other vertices via all these vertices. So it is via all that vertices. That is what it means. So when I say SP3, so you can go to all other vertices via via vertices 0, 1, 2. This is what it means. Okay. So now how do we do this? Now, usually the questions will be like this. So now use the following graphs. Now use Floyd-Warshall algorithm. That is one thing is given. So this is just an examples. So let us see what are the values of SP0. So what does SP0 tells you is, whenever we say SP0, SP0 is more like initialization. Okay. So as I was telling you in the beginning, whatever is written on the top, it indicates that you are going via if it is K, then K minus 1 vertices, right? So if it is, let's say, SP0, so this essentially means Wij. Wij is nothing but assign the weight age of that particular graph. That's all. Age weight of those particular vertices. That means if there is a vertices which is being connected, let's say 0 to 1, if it is connected, right? If it is directed like this, and it shows that whatever the weight for that particular is, that will be updated in this particular table. So now look at this. From 0 to 1, is there a path? So yes, there is. And what is the edge? What is the weight for that path? It's 1. So it has been updated. Likewise, from 0 to 2, is there any path? Direct path? No.
No.
So this is the initialization step. So SP0 tells you what? SP0 tells you that whichever is direct path, like whatever is the weight of the neighboring edges or the neighboring vertices, that will be updated in the SP0. Like now look at this, as there was no path between 0 to 3, no direct path, it is given as infinity. From 0 to 4, again it is not connected anywhere. Now look at this, it is a directed thing, it is a directed graph. So note, this is one thing that we have to understand here. Okay, over here we are using directed, so it's a Floyd-Warshall where we are using this, right? So now look at this part. Over here there is no direct path from 0 to 2, right? There is no direct path. So you see that is assigned infinity. But from 2 to 0 there is a path, and what is the value? -4. From 2 to 1, yes, there is again a path, but what is the value? What is the edge weight for that? It's 3. And from 2 you are not going anywhere else. So you see everywhere it is assigned infinity. Likewise, from 1 where all I'm going to 4, I'm going to 3. So you see this 4 is assigned with whatever the edge weight value is, that is -1. And from 1 to 3 I was able to go, and what is the edge weight for that? That is 2. So likewise, it essentially means SP0 essentially means what? Whichever vertices are directly connected, that corresponding weights are assigned with in this, and also whichever is not connected directly is assigned 0. Okay, so this is what it means. So that is SP0. Now let us look at SP3. What does it means? Okay, when we write SP3, so SP3 is again shortest path via 3 vertices. So 3 vertices, which are those 3 vertices? 0, 1, 2. That's all, right? So which are those 0, 1, 2? So that means 0, 1, 2. So that means now I can use these 3 vertices to reach any other vertices. Let's say if I want to go to from 4, I can go to 3, but what is the shortest path? 3. But you see this, I can go to 3 via 2, 0, 1 to 3, right? You can see this from 4. If I want to go to 3, it when I say SP3, it means that I am allowed to go via vertices 0, 1, 2. So whichever this is colored, I can go through these vertices only. So from 4, or if there is a direct edge connecting that versus, then that is perfectly fine. Then you can give the answer. But whichever is the minimum one, that will be updated in this particular table. Now from 4, you see this, I can go to 2 because I was allowed to go through these vertices when it is SP3. So from 4, I can go to 2. I'm also allowed to go to 0. I'm also allowed to go to 1, right? So this is all allowed for me. So from 1, I can go to 3, right? So I'm going to 3 via all these vertices, or I can even go directly if there is a path. So whichever is giving me minimum, that will be updated. Now from 4 to 3, what is the value that I'm getting? From here, if it is directly connected, I get what? 3. So from 4 to 3, it is giving me 3. But let us look at this path. If I'm going via this, what is the weight I get? 4 minus 4 is 0. 0 plus 1, 1. 1 plus 2, 3. So if I go via this way, that is also giving me 3. Or if I go via this way, is also giving me 3. Likewise, you can look at other vertices too. Now, let's say here, if I want to, now one interesting thing that you have to notice is from 0 to 0, there is no path. That means you can look at this. If there was a cycle formation, like let's say if this arrow was pointing here and this arrow was pointing backwards. So what would have been the weight for this? In that particular case, what would have been the weight for reaching 0? No, it won't be 0. Sorry, actually 0. Why 0? 0. So if this arrow was pointing towards 2, then the answer would have been 0. But right now, look at this, it is infinity. But you see this, if it is SP4, or let's say, okay, so now you understood what does this SP3 means? It actually tells you, you are allowed to go to all other vertices via these vertices only, that is 0, 1, 2, right? And if it is, let's say, SP9, then which all vertices you can choose? 0, 1, 2, 3 up to where?
8.
Up to 8, right? So this is what Floyd-Warshall tells you, right? So I am telling you about sp3, but now I want you to solve for sp4 and tell me which among these 4 options is correct. Hoping that you understood this. Solve this particular thing. It will take time. It will not even take much time. You just want to solve this. So now you know that if it is sp4, you are allowed to go to which all vertices? 0, 1,
0,
2,
1, 2, 3.
3. So these are the only 3 vertices you are allowed to, I mean 4 vertices you are allowed to visit, right?
Yes.
You can go to all other vertices via this. That is what it means, and update the shortest path, right? So all of you quickly solve this and give me the answer which among them is correct. So I'll mute you all. You can unmute and speak if you have to. So you can take another, like, let's say 3 minutes and solve this maybe.
So for the given graph, we can find the value still SP5, right?
Right. So that will be the next thing that we'll be doing.
At max, that is, we can do till SP5, correct?
Do any of you need more time?
Yes, sir.
Yes, sir. we would.
Okay. So take another 2 minutes or 1 minute. Okay, so let's see what are the popular responses for this. Okay, so most of you are giving answer as 10. That means you did not understood. Most of your answer is, sorry, not 10, but A. A as the option, but
Yes, sir. A.
A.
Yes,
Okay, let's see what is the right answer then.
I think so.
Actually, A is the answer.
Okay.
Yeah. So yes, so let me only quickly discuss this. How is this happening? Okay.
Can I discuss something? Can I say that how?
Yes, yes. Please go ahead. It's like very direct. So whatever she'll tell, we can. Please go ahead.
There is only. Can you please graph me? This is the option page.
Okay.
Previous page, yes. There will be only two option applicable, A and D, because 4 to 4 distance is 0, but other two graph is saying infinity.
Okay.
So we left only two option, A and B. And the thing is 0 to 3 is 3, but here is in D is giving 0 to 3 is in infinity. So is the correct option.
Okay, so like that you went, is it?
Yes. Just sorting out the things so that it will be easier to do.
Fine. So fine. That was one way, but okay, fine. So maybe we'll take care of this when we are, setting up options next time, so that
Yes,
you actually use
are,
you actually use this algorithm. So we'll do that next time. Okay. So all right. So would anybody like to discuss this algorithm? Anybody? So here is the solution.
So I can.
Yeah. Please go ahead.
But sir, I'm not sure pretty much. I mean, it is the correct way to implement it or not.
Fine, Himanshu. No problem.
Okay.
We can discuss. If you're going wrong,
Okay,
I'll just correct it. Yeah.
Okay, sir. So see, I just compared the first row from C0 to every vertex. So C0 to 0 is obviously 0. From C0 to 1, it is 1 as is it given in the graph. From C0 to 2, so see what we can do here. It is C0 to C1, sorry. It is 2.
So basically there is no C0 or nothing. It's just 0. The vertices name are 0, 1, 2, 3, 4. Okay, right? So from you see from 0 to 2, can you go from 0 to 2?
From 0 to 2.
Can you go to?
I can, sir. Yes, sir.
Sorry. Which path you will be taking?
Sir, from 0 to 1 and from 1 to 4 and then 4 to.
But you are not allowed to take 4.
4, yeah.
Because you see it is SP4. You can only go via vertices 0, 1, 2, 3.
1, 2,
That's
3,
all.
sir.
Okay, sorry.
Yes.
I can.
But you understood, right, Himanshu?
Right, sir.
You understood, right? Why it is infinity? Because you are not allowed to go via vertices 4, right? Once you are allowed, which vertices you will be allowed? You will be allowed in SP5. You can in SP5 you are allowed to go to vertices 4. At that time you will see from 0 to 2, this distance would be updated. It will not be infinity at that point of time. So now you understood that. Okay. Yes, now try other thing. Yes. Now from 0 to 3.
Sir.
Yes. Go ahead.
Yes, sir. So okay. So see from 0 to 3, we can follow the paths. We will go from 0 to 1, it is 1, and from 1 to 2, it is 1 to 3, it is 2. So we will add it up and then it will be 0. And from 0 to 4, since we have only one path, from 0 to 1, we can go with the weight 1. And from 1 to 4, I can go with weight -1. So it will become 0. And just by comparing the first row, because other one was different from this, I marked the A, and that is correct.
Okay. So well, that's okay. But you understood how you are actually applying this algorithm, right?
Yes, sir.
Sir, can I discuss my approach also? So actually,
yes.
What I was doing in the like in SP0, I am taking every vertex like 0, 1, 2, 3, 4. Then I'm
Okay,
connected.
1 minute. 1 minute. Right now, I just want you to discuss this algorithm for me, because strategy things we can discuss that, let it happen in the exam and all. But right now, do you know the algorithm first of all? That is something you should take from here. Do you know how to use this algorithm?
Yes, sir.
Yes, yes, sir.
So can you tell me how is this algorithm working here? You have the solution. Can you actually tell me how is this algorithm working?
Yes, you have to take the shortest path in SP4. Like in
Shortest
SP4,
path via vertices. Which all vertices? If it is like SP4, then which all vertices you?
So 0, 1, 2, 3.
one less than one less than what we have taken.
Whatever
SP
the
like
power,
SP4,
yes,
so we have taken less than less one. So
Correct,
B left that vertex, and B connect all the other vertex in the shortest in the minimum path. So that's how we use this algorithm to get the answer.
Okay.
But my
Yes. So
approach was a little bit different. So that's
okay.
Sir, can you please
What was
explain how it will be -1 and -4, sir?
if
In the
it is
column
correct,
2 to 3.
fine. I'll come to that. But let's listen what. Okay.
actually, what I was doing, it's correct or not, I don't know. I get the right answer, but in SP4, like what I do, I just take from SP0. So SP0 first I take all the vertex like 0, 1, 2, 3, 4. Then I see that what is the first connection of that particular vertex. Like if I take 1, so I will connect it to 3. And one more row I take, and I connect 1 with 4. So that's how I connect it, but it will take more time, I think. So that's how I am doing. Like in SP2, I will connect more than the connection. So that's how.
Okay. Okay, fine. No problem. But you can actually practice the algorithm what is given. So that will actually help you out eventually. Okay. So somebody was asking like, how is this -1 and -4 coming? Is it?
Yes, sir, it's me, sir.
Okay. So you
Because
see
I
this.
got all the values right except the 2, sir. I got 5
Okay.
and 2.
Okay, so let's see this. So where you are going from 1 to 4, right? From 1 to 4, you can directly go.
Yes, sir.
You don't have to go via any vertices. You can
Yeah.
directly go, right? That is why it is given -1.
-1. I'm asking for
Right?
2 to 3 and 2 to 4, sir.
2 to 3, okay. 2
Yes,
to
sir.
3 is okay. So from 2 to 3, right?
Yeah.
So now which all path you can go through? You can go through
2, 1,
1, 3,
Ah.
or you can go
2
to
to 0,
0,
0 to 1, 1 to 3.
1 to 3. Which is minimum?
Shortest path.
Shortest path. That is, you have to find out from
So
2
in
to
both
1.
it will be 5 only, no, sir. -4 plus
-4,
1, it is -3. Okay, okay, sir.
It's -3.
Now you got it?
-1.
Yes, sir, yes, I
one
got it,
is
sir.
going to-
I thought it's +3.
Ha.
Okay,
So
sir.
it will give you -1. Likewise, from 2 to 4. Now 2 to 4 you have to go, right? So which cycle you will be choosing? 2 to 0.
1.
2 to 1, 1 to 4.
Okay.
No, you will go 2 to 0. 0,
0 to 1.
2 to 0, 0 to 1, 1 to 4.
1 to 4. If you go via this, it will give you 2, right? But you will choose this path because
Okay,
here there is
sir.
a least weights, right? So you will go.
Okay, sir.
Okay. So now you understood that? Yes.
Yes, I understood, sir.
Okay. So likewise, SP5, I'll just directly discuss this because we don't have much time. Now look at this part. Initially, what we got was like, I'll show you in SP4. You notice this in SP4 from 0 to 2. Sorry, from 0 to 4. No, yeah, from 0 to 2. What was the distance? It was infinity.
Infinity.
Right? But look at this. From 0 to 2, now it has been upgraded to
4.
Right?
Because
So now how is
SP5, so
that
we
happening?
can take 4.
Yeah.
Now since this is SP5, you can go via vertices 4.
Hmm.
So now you see this everywhere it has been updated, and this whatever the distance you will get from here, that will be the minimum distance to reach that particular vertices from any other vertices, right?
Yes.
Like if I want to tell you what is the minimum distance to reach from vertex 1 to 4, so your answer should be -1. What is the minimum distance to reach from vertex 2 to 2? The answer will be 0. Or from 2 to 4, it will be -4. Likewise, if I have to ask you what is the minimum distance to reach vertex 4 from 3, then what is the answer?
0. Infinity.
Infinity. Because look at this, from 3 you cannot go anywhere.
Yes, sir. Cannot.
There is no path. That is why it is infinity. So you understood, right? Now look at this, from 0 to 0, it has been upgraded to 0, which is that cycle we are following here. See, look at this. It actually goes to 1. 1
4,
minus 1, 4,
0.
0. Then 4 to
And
2,
to 2.
which is
Four.
which is plus
4.
4, and 2 to 0, which is minus
Minus
4, and it has been upgraded to 0. Now you understand this, right? So now look at this. This is actually forming a cycle, isn't it? Right? So
Yes.
one thing you have to understand this. What is the weight of this cycle?
0, 0, sir.
0. So if I want to go
0.
to 1, from 1, what should be the weight? 0.
0, sir.
From 4 to 4, from 4 to 4, what will be the weight? 0.
0, sir.
2 to 2, what will be the 0?
0.
Sorry, what will be the weight?
0.
Because the weight of this cycle itself was 0, and it cannot be negative. You know that the minimum weight, it should be 0. It cannot be negative, right? So now you understood that to reach the same vertex in a cycle, whatever is the weight of that particular cycle is the weight to reach that vertex, right? So that is one take you can take from here, right? So this is what we do in Floyd-Warshall algorithm. So this is all for today's session. And we already
Sir,
took like 10
just
minutes.
a simple query. In that picture, if we take SP1, here 3 we are not allowed to take, right?
SP1 means only you are allowed to go
0
via
and 1.
vertices 0.
But
Just
whenever
0,
3 is
not 1.
directly 0. Oh, SP0 is 0. SP1 is 0 and 1, right?
SP0 is not 0. SP0 is like whatever is the direct connecting edges, that is something assigned.
Okay.
Ha.
This is SP1, 0 is SP1, and 0 and 1 is SP2.
Ha, correct.
Okay. Then if we take SP2, we cannot take 3. But here 3 is directly connected, so we can go 1, 2, 3, 2, right?
Yes.
Okay. Only those are directly
Yes.
connected, we can calculate this thing.
Because that is essentially SP0, isn't it? Whichever is directly connected, that is SP0, isn't it? So one thing you have to notice this.
That means we are not going to take 1 to 2, 1 to 2, because it's coming from 1 to 4 and 4 to 2.
Correct. So one thing that you have to understand, unlike Bellman-Ford, what is this? Floyd-Warshall algorithm, your SP2 or SP3 or SP4 or SP5 is independent of whatever it is, right? If you want to find out SP5, you don't have to really find out what is SP4, right? You can actually find what is your SP5, isn't it?
Yes, sir. We can do that.
Yes. So in Floyd-Warshall algorithm, if I have to tell you find out SP3, you need not find SP0, SP1 or SP2. You can directly find
SP3.
Sir,
all of you?
Sir, in exam, this kind of maths will come. We have to choose what the SP4 or something.
See, actually giving you SP5.
What kind of question can be possible with this algorithm that I'm asking?
We can actually find your.
Not able to hear you, sir. His voice is very low.
Okay, so you see this, if it is an exam, so if I have to give you, like, I can go maximum with 5 or a 6 word. Okay, I'll just mute all first. So you see, if it is an exam, all I can do is I can just give you a matrix and say that, okay, find out all pair shortest paths, just like this, right? So in that case, if I just give you and tell you, like, find all pair shortest path, and if it is of 5 vertices, then what is that I'm indicating you to find? I'm asking you to find out SP5. Understand that, right? Because SP5 will give you what? All pair
vertices.
All pair shortest path you will find only in that SP5, right? If it is of 5 vertices. So understand this. So this is one way of asking things, right? You might get confused that time. Okay, which should I find? SP0 or SP1 or SP2 or SP3? It's actually giving you, it's actually the SPN, whatever ever n is the number of vertices, that is actually which will give you the all pair shortest path, right?
Sir, one more question. Like, if SP5 is asked, so we can choose one vertex, like we can pick 0 and we can find all shortest path from 0. Then we can do the same with 1, then 2, then 3.
But that will take a lot of time, you know.
Okay, so that
will take a lot of time, yeah.
Okay.
Yeah. So yes, this is all for today's session. We'll share you this.
Sir, one thing. If I have only 5 vertex from 0 to 4, that means only SP5 is the maximum. Yeah. we can do more.
No, that is the maximum.
Okay.
Yeah. Okay.
Yes. Thank you.
Yeah. Thank you all then.
Okay. Thank you, sir.
Thank you. Thank you. Good night.
Thank you, sir.
Good night.
Thank you.
Oh, sir, can I ask something? If someone fails in some subject at end term, then he or she has to give the whole quiz 1, quiz 2, and end term again, or only end term exam?
Repeat whole.
Repeat whole everything.
If someone fail in some subject in end term exam, right? Then he or she has to repeat all quiz 1, quiz 2, and end term, or he or she has to give only the end term exam again?
I
Repeat
think
that particular subject from week 1.
Any particular subject.
I believe he has to repeat everything.
Quiz 1, quiz 2, and end term all.
All.
Yes, all.
That's I'm asking. Thank you.
Thank you. Good night.
Good night.
Good night, sir.
Good night. Thank you.
Thank you, sir.